All right, welcome to CS 891. This course is going to be focusing on topics related to concurrent and parallel programming in Java on the Android platform. And what I'll do today is give you an overview of the course, and then we'll start diving into the first set of material, which hopefully will be review, as you'll see in a second. And I'll also give you pointers to some of the information on the website as we go through this, and you can take a look at the first programming assignment, which I'll talk about later. So I'm Doug Schmidt. I've been teaching at Vanderbilt since 2003. I'm also the associate chair of the department. And something just went awry. There we go. That's back. It's weird. I'm also the associate chair of the department of the computer science program, and have taught some other courses that you may have a chance to take at some point along the way if you haven't already. I teach a course, co-teach a course called Solving Big Problems with Mobile Cloud Computing, which is a so-called university course where we team up computer science, software developer folks with other people from other parts of campus to work on interesting projects to solve cool problems in the context of mobile cloud computing. But let's start by talking about CS 891. Okay, so let's talk a little bit about the course philosophy. I've been programming for a very long time, and it's been my experience that just talking about concepts and abstractions is useful, but doesn't really get to the meat of what's interesting about learning to be a good software developer. So we're going to talk, especially when it comes to concurrent and parallel programs, which is the focus of the course. So we're going to spend a lot more time going and doing things with a hands-on approach rather than just discussing things at a very high level of abstraction. So we're going to be focusing on how to write code, how to read code, how to make code more efficient, which of course is really the goal of concurrency and parallelism, how to take advantage of all the hardware out there that we have that makes it able to run, if you do it right, run much faster than would normally be the case. And along the way, we're also going to be applying a bunch of really cool object-oriented programming techniques and patterns, as well as functional programming techniques and patterns, which you've probably been exposed to object-oriented programming before. Some of you who have programmed in languages like JavaScript maybe have touched on some of the functional stuff, but most people find that kind of new and different. So we'll be doing a lot of software programming, a lot of testing, and you'll get a lot of feedback in the course. So what are we going to cover here? As I kind of alluded to, we're going to cover the concurrency and parallelism features that are predominant in Java 8. I'll talk more about what Java 8 is shortly. Java 8 is an interesting combination of object-oriented programming and functional programming. We're going to focus primarily on the features in Java 8 that are the newer and more powerful functional programming features, and you'll see why we'll do that. We might talk a little bit about some of the Java 7 and before features with concurrency and parallelism if we have time. Those are somewhat harder to program and are really not cutting edge the way that the stuff we'll be covering will be. We'll also be spending a little bit of time with Android, the user interface, some of the inter-process communication mechanisms. We'll have some examples in there, for instance, dealing with communicating via sockets and TCP/IP to web resources that are out there in the cloud somewhere. So you get a little bit of experience with that. I'll be teaching a course in the spring semester that will go into more of the Android side of things and more of the inter-process communication stuff. So we'll get there if we have time, but I think we'll have plenty of things to do with the Java 8. So this is just a little bit of stuff we'll be doing. And I'll talk about that when we start talking about the assignments. We'll talk a little bit about mobile and web programming. That's not really the main focus of the class, though. And then along the way, I'll mention patterns and frameworks. You'll get a lot of experience with frameworks and patterns, especially with a functional programming perspective, which is kind of cool and new in some sense. If you are a little rusty and need to come up to speed on some of the things, especially Java, I'll cover it briefly today and maybe Monday, and we should be pretty much done with the background part of the course. If you need a refresher on that, if you haven't done a lot of programming in Java before, then you could take a look at our Android specialization, which has a bunch of videos that talk about how to program Java for Android, and that's probably enough to get you over the hump. If you really don't know anything about Java, this might not be the best class to take, because I'm assuming that you have a pretty good command of basic Java stuff. So we'll talk about that. I also assume people here know or can learn Git quickly, and there's also some resources available to learn that on the website too if you need a refresher, or go to office hours and ask help from the TAs. I'll talk more about office hours in a second too. All right, so what we'll be covering, and I'll hopefully get to the first part really fast, is sort of a brief overview of the object-oriented parts of Java. This is kind of the classic part of Java. You'll learn, which I think you already know, hopefully from CS 101 or the equivalent, will be things like classes, inheritance, and polymorphism or dynamic binding. We'll go over that stuff quickly. I'll show you some examples. You'll have a programming assignment, which is due in a week, which is just to kind of make sure you're up to speed on those things. Shouldn't be hard to do. It's a pretty simple assignment just to get everybody up to speed with the tools and kind of refresh your Java knowledge. And then we'll spend time, probably most of next week, covering the basic Java 8 features, lambda expressions, method references, functional interfaces. And this is the really cool, newer stuff. You may or may not have seen this before. It's really interesting if you haven't. Even if you've seen it, I'll undoubtedly cover things that you haven't seen much before. Then we're going to focus, the bulk of the class will be on concurrency and parallelism, and we'll be focusing on two major frameworks in Java 8, one of which is called Java 8 streams. And first we'll look at the sequential streams, and then we'll cover the parallel streams. And then we're going to cover something else called completable futures. So parallel streams, as the name implies, is about parallel computing. And it's really cool, and it takes advantage of the Java 8 functional programming features. And then completable futures are really more of a reactive asynchronous event-driven model. And it's also interesting, very fascinating way to program. And in some cases, actually more scalable and efficient than the parallel streams approach. So you'll get a chance to play with all these things. You write programs. We'll cover them in great detail, talk about the patterns and so on. Again, we'll show some examples of how to do HTTP communication and HTML parsing, which is kind of there just to give you the background. You really don't have to learn this stuff other than to look at the skeleton code I'll give you for the example programming assignment pieces, the scaffolding that you'll use to do your part. And if you're curious, then we can go into that in more detail. And then there'll be discussions about patterns. Hopefully people here have taken CS 251, where hopefully you learn about patterns. When I used to teach the course, we really covered patterns in detail. I don't know how it's being taught now, but you'll understand good ways of doing design. And surprise, surprise, even though Java 8 has lots of cool functional programming features, a lot of the same patterns still apply. And they just are applied in a slightly different way. We'll bounce around, like Tigger from Winnie the Pooh. We'll bounce around a bit through these topics, but that's more or less what we'll be covering. We'll cover the Java stuff first, and then we'll go into the concurrency and parallelism stuff next. The course has a number of modules. Each module has lessons. Each lesson has parts. Each part has a single lecture that's part of it. And what I'll be doing is screencasting everything, and then shortly after class is over, depending on my schedule, I'll be uploading the screencasts of most of the material, not everything. Like, I won't upload the solutions to the web, but everything else will more or less go up. And you can then go ahead and take a look at my website, which will have a link to the slides, PDF version of the slides, and also to YouTube, where I'll have a playlist for all the videos for what we're going to cover. So you can always go back and watch. And we'll talk about that more a little bit. And we'll have little segments, and we might stop at the end of each segment and kind of talk about, discussion questions, give people a chance to interact and so on. We'll have quizzes every other week starting next Wednesday. And this will cover the material that's in the lectures before. Obviously, on Wednesday, we'll have had 2 lectures, so we'll cover that. All the quizzes and the one final exam, there's no midterm, will be closed book. And good way to study for all these things are to watch the videos. So you'll discover that the best way to learn it is to go back, and I'll talk more about that in a second. But basically, you can go back and watch the videos again. If I talk too fast, you can slow it down. If I talked about stuff you already knew, you can speed it up, or you can go through the material pretty quickly and get another perspective. Hopefully, knock on wood, we'll get the quizzes back the next class session. So if it's on Wednesday, I'll give you back the quizzes on the following Monday. And one of the great things about having a somewhat smaller class is that I can hand them back to you. You don't have to go to office hours to pick them up like you might have done in some other courses. And that also gives me a good excuse to get to know everybody's name. There'll be a cumulative final, which honestly usually focuses on most of the stuff at the end of the course. So maybe a few questions that come from earlier parts. But we want to make sure that the quizzes cover everything, and the final will cover what's left. And the final exam, I think, is early this year. It's December 9th, which is a Saturday, kind of a strange time for a final exam. And it starts at 9 o'clock in the morning. It shouldn't say 9 p.m. to noon. That would be one heck of a long final exam. We're going to have, like 13-hour final exam. We're going to run a marathon in part of it. And all this information is up on the website, which you can always refer to, and I'll show you that in a second. Let's talk briefly about the assignments. So the assignments will all be done with Android Studio, which is the preferred development environment for Android. It also doubles as a Java development environment, and you'll learn that when you do the first assignment. You can use any IDE you want. If you're a Eclipse fan for some reason, or you want to use IntelliJ, which really Android Studio is IntelliJ plus a few more things, you're welcome to use that. But your final solution that you submit for review and for grade especially has got to be done with Android Studio 3.x, and we'll talk about what that means in a second, and using the NuGet version 7.1, which is API level 25. And I'll talk more about why we want you to use that particular version. The main thing is to make sure that we can have a common version for reviewing and grading so that nobody gets burned by version skew, because sometimes things change a little bit between versions. You'll need to install Java 8. You can go to this link at the bottom of the web page. I'll post the web page, I'll post the slides so you don't have to worry about writing this down. And that tells you where to get all the software to install. It's really easy, but make sure you have Java 8 because you'll be using the advanced Java features. The Android Studio gives you all kinds of cool things for developing apps with Java for the Android platform. And for the first couple of assignments, you won't have to use all the stuff there. In fact, we'll largely be giving you shells that do the GUI part for the most part, and you'll be filling in kind of the brains of the computation. So you'll have apps to run, and you'll have apps to play with, and you can look at the code, and it'll be really cool and flashy. But we're not really focusing on the UI part in this class. We're focusing on the concurrency and parallel part. And you got to get NuGet, as I mentioned before. All the code, all the example code and assignments will be available on my GitHub account. So you can use that to get access to the code. You'll need to learn how to use Gitlab. Gitlab has the benefit that you can make the accounts private, so you don't share them with other people, except for me and the TAs, the graders. We'll talk about how to do that. And every once in a while, you may have to do a git pull and update things. Hopefully at this point, the skeletons I give you will be pretty finalized and things won't change a whole lot. But it's software, so inevitably there'll be something along the way that needs to be updated. So you may have to get used to learning simple git commands like git pull and so on. And the other great thing about using git conscientiously is that if your computer goes awry, you will have a copy saved that you can get back easily. So good habit to get into is commit early, commit often, and get your code pushed up to your GitLab account so that you don't have problems and surprises. The very first thing you need to do is set up your GitLab account. And I sent out an email to everybody who I had on the mailing list in the class as of a day or two ago. So if you didn't get an email from me, then do one of two things. Check your spam folder to see if it went to spam. And if it's in spam, put me on your whitelist or whatever so my email doesn't go to spam. And if you didn't get an email, send me an email really fast and tell me that so I can resend you the instructions, because they give the instructions on how to get started. The programming assignments we're going to do, they're all going to build on each other, and they'll ultimately give you lots of experience with Java 8 and concurrency and parallelism mechanisms that are available on Java 8 and Android, which is Java 8 at this point for the most part. And you can go to this link to find the assignments. The first one's been posted already, assignment 1A. The assignment we're going to be doing is going to be an image crawler app on Android. And what it'll eventually allow you to do is you'll give it a URL, and it will go out and it'll crawl from that URL through some number of layers, some number of levels down through the links. And every time it finds an image, it'll download the image, and then ultimately it'll display it. So I have a test directory that kind of exercises all this stuff. And so you'll get a chance to play around with this. And I'm going to give you, this will be done incrementally, as we'll see in a second. I'm going to give you some code that does the solution using sequential Java 7 features. And then your assignments will be to change that code to use Java 8 streams, sequential version at first. Then we'll do Java 8 parallel streams. Then we'll do Java 8 completable futures. And so we'll keep adding and changing and using the new capabilities in Java. So by the time the course is done, you'll have a chance to play around with all these different features. And you'll have a pretty cool app that will visualize things in a neat way and also demonstrate all the concepts. So we'll kind of tweak this stuff as we go along. It might change a little bit, but that's the basic idea. The way we do the assessment in this course might be a little different from other courses that you've had. And I've done this for decades now here and at other places, and it works great. The way it works, well, first of all, you absolutely have to submit your stuff on time. And I'm a real stickler for that. You'll find I'm pretty laid back, but there's a few things that get me really fired up. And one of them is not being on time. Because if you're not on time, it throws everything into a tailspin, because I have to look at all the code in the first pass. And if people are late, then it makes it hard to do that. And hard to get the feedback to people in a timely way. If you take a look at the frequently asked questions page link here, you'll find out sort of more about how all this process works. So basically what you need to do is you'll need to submit your program by the due date, the initial due date, and then I will review it. And then I will, and when you submit your program, what that means is you have to commit it to your Gitlab repository. And I'll have a little form I'll send to everybody so you can kind of fill that out and tell me what your Gitlab address is and other information that I can use in order to easily automate the process of pulling it all down into my account and then reviewing it. And then I'll give you feedback. And usually I get the feedback back to everybody within a day or so, which is why it's important to be on time. And then you'll get a chance to revise your program based on my feedback. And then you'll resubmit that, and then the TAs and the graders will review that, and that's what will get you your grade. So your final grade for an assignment, and there may be some little variance here, but the basic idea is you get a chance to improve it and revise it, and then we grade you on the revision. So, in theory, people should do really well because you're getting multiple chances, multiple bites at the apple. You're going to get feedback. You get a chance to go to talk to the office hours. And so, in a perfect world, you should do really well on the assignments. It's never a perfect world, and I'll talk more about that, but that's the opportunity you have to get it right. Now, here's the deal. This is kind of a special thing. Most other classes, you get no feedback whatsoever except maybe a grade at the end and a few comments from a TA who may or may not really know what they're grading. So here you're getting like the Rolls Royce of this stuff. But there's a price you pay for that privilege of getting a in-person review. You have to put time into getting it working for the first submission. So if you submit just utter gobbledygook and say, well, you give me all these comments, I'm just going to submit some half-baked version, then bad things will happen. And even worse, if you don't submit for the initial submission, even though we're not grading that, if you just don't submit it at all, you're going to get a 0 on the assignment. So you've absolutely got to be on your ball here. You've got to keep up with this stuff. Don't fall behind. That's the price that we pay for getting all this great feedback. Another thing I'm going to emphasize, because this sometimes gets us in trouble, sadly, everything in the course is meant to be done as individuals, no group projects. Other courses we teach have group projects. So programming assignments need to be done as individuals, and quizzes need to be done as individuals. And I'm going to emphasize that here. This is all being recorded. I should have had you sign a form. I don't want to have any confusion about this. Work has to be done individually. And over time, people make mistakes and they get busted. And because I review everybody's code, it's easy to see when people plagiarize. So don't do that. It's very annoying to have to put people in front of the Honor Council. And we've done that before, and it never turns out well for anybody. So just take that as your warning. There's some criteria for the scores. The program has to run correctly. If the program, you run your program and it crashes or it gives the wrong result, 40% off, right? So you've got to get it working. Now, that's for the final submission. For the intermediate submission, it has to compile, right? And you have to make a good faith effort to get it to work. But when you turn it in for the grade, execution correctness is important. Now, for the first assignment, you'll be like, are you kidding me? This is so easy, right? And the first assignment, as you'll see, actually comes with JUnit regression tests. So it's really easy to tell if your program is working by the time you submit it, because it should pass all the tests. And if it doesn't pass the test, then you know kind of what to fix. But as we get to the harder stuff, the concurrency parts and the parallelism part, it's not always easy to get it to work. So you'll have to put some thought into that. And then we have other scores for other things, like how do you structure the code and comment it and stuff like that. So just get in the habit of doing your programming assignments with good commenting style and so on. And you can take a look here for details on what I'm expecting people to do from the point of view how they write their code. The course is weighted as follows. Quizzes, well, probably 6 or 7 quizzes, depending on how things play out with breaks and so on. That's 40%. Programming assignments, 40%. Final exam, 10%. And what that means is the final exam isn't too long, right? So it's probably going to be 3 pages long or so, maybe 4 for the grad students. And 10% participation. And this is something else that I'm a real stickler on. Some people, some classes, it's like, you know, show up, don't show up, we don't really care, no big deal. This class is different. And the reason why it's different is because in my experience, the people who don't show up to class and the people who don't pay attention and participate in class end up doing very poorly. And it's really frustrating for everybody involved. It's especially frustrating when it's the second semester of the senior year and there are people who are not going to graduate because they just don't put the time into the course. So fortunately, it's the fall semester, so that should be less of a problem. But you know, again, this is just giving you fair warning. You have to be involved. And so there's a 10% participation grade, and because it's a relatively small class, it's easy to know everybody's name and know how people are participating and so on. So participation is roughly 5% attendance. And if people aren't showing up, and it's also usually easy to tell who doesn't show up, because people who don't show up tend to show up for quizzes, but then they don't show up the next class. So I end up with a quiz. And I'm like, so-and-so hasn't been here for 3 or 4 classes. They're not here. So it's easy to tell who's not showing up. So showing up is part of it. And then the second part is being involved and participating. Every year I always do the freshman orientation night. That was last night, right? For the incoming freshmen, we get together and go over to the Commons and tell people, like, this is the beginning of a wonderful journey through undergrad education, and any questions. And I always emphasize, don't just be a bump on a log. Don't just sit there like a lump and expect people to pour knowledge into your head, right? You've got to be engaged. And in a lot of ways, that's what being a Vanderbilt student is all about. That's why you're at Vanderbilt and you're not at some podunk, community college. No offense to podunk community college, but you're here for a reason. And part of that reason is to learn to be leaders, to learn to be able to be engaged. That's what separates a Vanderbilt student from other places. And so I'm going to hold people to that. And you'll see I'm a pretty easygoing guy, so nobody gets made fun of if they ask really dumb questions. But asking questions, being involved is really, really key. And so I'll try to provide structured opportunities to ask questions with various prompts and things, but just being involved is important in the class. So if you do not participate, if you just sit there the whole semester and never say anything, you're very unlikely to get an A in the class. So I'm just warning you, right? So you've got to be involved. And again, it's a little bit out of the comfort zone. I know we're engineering students. People don't always talk as much as the A&S people, but that's okay. You're going to have to get practice, so you might as well get practice being involved in a nice, comforting environment where people want to be engaged, and I want to hear what you have to say. And it also makes the class like a million times more fun because people are actually thinking about this stuff. And I guarantee you, if you're sitting there and you do not understand something, there's probably at least half the class that also doesn't understand it too. So make sure that if something is going whizzing by and you're like, wait a second, that didn't make any sense, don't hesitate to stop me and we'll talk about it. All right, quick discussion about setting things up. I think, let's see. All right, I think I already went through a lot of this stuff. Here's something that's important, though. Make sure that you get Android Studio 3.x. I think this is the current version, 3.0 beta 2. And you wonder, why are we using 3.0 beta 2? The reason is because that version of Android Studio has way better support for Java 8. The official version, which is 2.3.3, I think at the moment, does not have good support for Java 8. And so it's really frustrating and hard to debug your code and hard to walk through your code. So that's the version we'll use. I've been using it. Seems to work fine. They'll probably release the official version here shortly. You'll have to set up version AP 25. It's also fine if you have other versions, but just make sure you have version 25, and you can learn about how to do that here through the prompts. And then set up an emulator for API 25 as well. Some of you may actually have Android 7 phones or phones that have been upgraded to Android 7. Mine is. It's a Galaxy S8, and it has Java 7. If you have a phone, that's the best way to debug and run stuff because it'll be really fast. If you don't have a phone, you can use the emulator that comes bundled with Android. I strongly recommend, if you're running a machine, either a Mac or a Windows machine, with Intel processor on it, or processors or cores, make sure that you install the Hacksum accelerator, which will make debugging and running your code on the emulator tolerable. If you do not do this, it will be incredibly painful and slow. So try to get that installed if you can, and you can come to office hours, and hopefully people will help you. Finally, you can actually, the other cool thing about Android and Java, all the code is open source, so you can get Android code for browsing here. You can get the source code to download here. Likewise, for Java 8, you can look at the source code for browsing or for downloading. And it's really fun. I've spent lots of time looking at Android code, lots of time looking at Java 8 open source code, and it's really interesting to see what they do, especially the concurrency and parallelism parts, which are written by some of the absolute gurus of concurrent and parallel programming in the world. One of the guys in particular name is Doug Lee, who's a longtime friend of mine. And every once in a while, we'll come across something really obscure, and everybody will be stumped. Why does it work this way? And so I can call him up and ask him, and he'll usually tell me what the reason is, which is kind of fun. So that's helped us out a few times along the way when we were puzzled by how things worked. So to summarize, as always, you'll get out of the course what you put into it. There'll be a lot of work. What I've tried to do so that we smooth things out, you'll get a lot of assignments where they're broken up into parts. So we'll have part A and part B. And each part is relatively small, but the due date is relatively soon. And the reason I do that, even though it is actually a lot more work for me because I try to review all these things as they go whizzing by each week or so, is I found that no matter how much time you give people, you'll end up starting at the last minute. Yeah?
Sorry.
All right, so I try to smooth the assignments, the programming assignments out, so you'll be doing a little bit of stuff rather than procrastinating to the end and trying to do, 3 weeks of worth stuff in a night, right? Which does not work, especially with the programming assignments we're going to be doing here. Don't miss deadlines. That tends to get me very upset. Participate in discussions in class and on Piazza. We have a Piazza page, which you should be able to go to, and I'll post messages. That's the primary way henceforth we'll communicate. So I sent out the email to everybody just because you didn't know to check Piazza. But from now on, I'll be posting things there, saying things like, here's the assignment, here's the form, the Google form to use to tell me where your assignment is, blah, blah, that kind of stuff. Another thing, another big point. So classic problem. People sit in class. I'm guilty of this too, I'm afraid, in my regular life. And they browse in their computers and their cell phones, and they don't pay attention. And then they come to office hours, and they're like, could you explain blah, 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 where blah, blah, blah is what we just talked about in the lecture? So I have found, in a world full of quasi-ADHD people like myself, that if I remove the temptation, people pay more attention, right? So I'm very sorry. I know everybody loves to multitask, but it's really hard to keep up with this stuff. So please don't use your computers or cell phones in class, or we subtract points like evil Snape. The other thing is there are people who occasionally figure, I will sit there pretending to pray with my head down and my cell phone in my lap. I have ESP, I can see that, and those people do poorly. So please keep your laptop shut. That will make everybody go much more smoothly, and you will actually get a lot more out of class. The other good news, of course, is that all the material is recorded, so you don't have to worry about typing in notes, because you can go back and rewatch the lecture at double speed and get it all back again. Lots of resources, online forum, office hours, textbooks, which are on the website. You don't necessarily need them, but they're cool. Lecture videos, lots and lots of links and slides. You'll see all kinds of things to learn more about any given topic. And if you go to this website here, then you can find the course web page, and that'll have pointers to everything. It'll have the office hour schedules, which I think we have every day of the week covered, which is great. We have 4 for graders who are all real good. They took the class before and have done well. And then we also have the videos and the PDFs of the slides and the online stuff and the repository with all the assignments and examples, etc. So there should be lots of opportunities to learn. Please try to resist the urge to send me email directly and instead use Piazza, unless it's confidential, obviously, if you need to talk about something, if you've had a death in the family or some other issues, or you want to schedule a meeting to talk, that's fine. Don't worry about sending me email. Just don't send me email saying, could you explain this thing in assignment, blah, blah, blah. Because if you post it on Piazza, then when I reply, everybody else gets the benefit of my response. And chances are one of you or one of the TAs can jump in and answer the question, even if I'm not busy, even if I'm busy. The great thing about these topics is they're super hot. If you take a look here, this website's actually a few years out of date, but it tells a trend that still exists today. People want computer science talent, and that's what you're going to get here. You're going to get absolute cutting-edge computer science knowledge in this class. I think for the second year in a row, the CS majors had the highest average starting salaries in the engineering school, beating out those chemical engineers who used to have the highest starting salaries. The oil price going down has hurt them. And I think it was over $100,000 as the average starting salary, which is pretty darn cool. The downside is that the people who were getting the high end of that were all going to Silicon Valley, where rent was $5,000 a month, but that's a different story. So, but the good news is what we're going to learn in this class is super duper in demand, and people will fall over themselves to hire you if you master it. We need to have an evacuation plan. So if something goes wrong, run up those stairs and out the building. We're hoping that we never have to use that, but I'm obliged to tell you the evacuation plan.